IMIP is an international cooperation project financed by the Interreg Sudoe program through the European Regional Development Fund FEDER. The main objective of the IMIP project was to design, validate and implement an innovative construction system based on natural bio-based materials, basically wood and cork, to improve the energy efficiency in public buildings. Wood and cork are local nature resources whose technical characteristics make them excellent raw materials for construction and rehabilitation. Wood is a lightweight biological material whose industrial transformation and production process emit fewer greenhouse gas emissions than its competitors, traditional construction materials, but also stores atmospheric carbon. Wood species available in the Sudoe area for manufacturing construction products are generally softwoods, especially several pine tree species, but the most common on that is present throughout the region is maritime pine, Pinus pinaster aid. Pinaster pine is a fast-growing variety, so the regeneration of the territory occurs quickly. Therefore, it is a moderately resistant wood. One of the objectives of the IMIP project is to develop the possibilities of this forest mass. On the one hand, this wood will be used due to its rapid growing and extension. And on the other, construction systems are developed with the less wood technologies to provide this system with high performance. Cork is a natural and renewable product that is present in Portugal and some regions of Spain and France. It is commonly used for stoppers manufacturing, but also for the fabrication of building products with different processing degrees, such as a terminal or acoustic boards or granulated products. Southwest Europe has a few buildings made of wood compared to the other European regions. It is therefore where the potential to mitigate substitution is maximized. Based on these facts and opportunities, the project consortium, formed by 9 patents and 3 associates entities, has created a wood-based construction system that takes advantage of the low-cost wood available in the regions for a creation of a product with higher added value compared to those currently being produced by the industry, as for example wooden pallets for good transportation. It's characterized by its low environmental impact basis being fully complete with building construction standards. It is in accordance with the circular principles. It is based on renewable materials and it can be disassembled, reused, and recycled. The construction system developed consists on different types of elements, vertical and horizontal, with different functions, partitions, and structural elements, and with different parametric compositions. The product developed includes slabs, covers, walls, and sandwich panels. The elements developed are characterized by their lightness, their high performance, and low cost because of the material used, low-quality wood and cork-based insulation, and are fully compatible with existing products on the market. Prototypes of these elements have been manufactured and tested in certified laboratories to determine their structural, acoustic, thermal, and fire resistance, and to verify their durability and dimensional stability, thus providing all necessary data for their later use by prescribing technicians, companies, and public administration in the development of projects. In order to demonstrate the feasibility of the IMIP construction system, 4 pilot experiments have been carried out. 2 small buildings have been produced using the elements designed and tested. The first pilot is a small construction designed for emergency situations, which can be easily assembled, disassembled, and transport. To validate this fact, the project has managed its installation in Lisbon, Portugal, and its later disassembled, transport, and reassemble in Valencia. The second pilot is a 2-story structure built entirely with the interconnect models designed in the project. Both buildings have finally been erected on the campus of the Universidad Politécnica de Valencia. The third pilot experience consists of a renovation residential municipal building in Espadilla, Castellón, where the existing roof based on traditional construction materials, which was in a very poor condition, has been completely replaced on the IMIP roof panels, This has made it possible to confirm the compatibility of the IMIP system with traditional building system and materials, and its potential for use and rehabilitation of buildings. Finally, a virtual reconstruction action of an abandoned rural ruin has been carried out, using the panels combining the IMIP construction system with the existing ruins of an abandoned rural construction. With this last action, we have shown that it is possible to intervene in a prefabricated and industrialized way to optimize execution times, economize on processes and budgets, while sustainability rehabilitating buildings in their different states of conservation. Additionally, a web-based application has been developed which, based on the VIM methodology, makes it possible to obtain energy and environmental analysis of building elements. The web application allows the import of BIM models in standard IFC format, as well as the visualization and interaction with the geometry and web environment, in order to subsequently export the models to specific calculation tools. This way of projecting reports very valuable information in relation to the impacts and energy efficiency of the buildings during its design phase, which speeds up decision-making when it comes to improving its benefits by adjusting the parameters of the system both at the level of insulation and resistance of materials in structure and construction values. Starting from the same VIM model developed during the design process and through the standards export files, a work phase has been implemented through the immersive virtual reality application that integrates the user with a 3D visual spatial model of the solutions developed. In the IMIP project, the objective of this work mode is to facilitate a better visual understanding of these solutions. The application is also interactive, where the user can interact directly, virtual and in real time, with the prefabricated panels indicated above and at the building in which they have been installed. This new virtual world and metaverse establishes a new work platform where both remote work meetings with multiple users can be held, as well as being used to determine changes at the spatial level of adjustments of the details at the construction level. In order to maximize the impact of the results obtained, different activities have been carried out to transfer the knowledge acquired to the main interested groups, including the scientific community, society in general, professionals in the sector, architects, engineers, builders, carpenters, and political decision makers. To this end, training actions have been carried out aimed at different professional profiles, and the information on IMIP products has been included on the official tools and documents commonly used by technicians for the drafting of their projects.